coding. And on the previous lecture, we considered examples of machine learning problems, and we considered main directions in machine learning. They are supervised learning and unsupervised learning. And supervised learning includes classification problem, regression, time series forecasting, generative models, and so on. And unsupervised learning includes clusterization problem, dimension reduction, and so on. There are other fields of machine learning, for example, large field of machine learning, very important today, reinforcement learning, so-called. And there are other fields in machine learning, for example, online learning, maybe machine learning theory, and so on. Let's recall what is supervised learning. We have a set X, the set of samples or objects. This set is called sample space. And we have another set Y, the set of responses or labels. And there is a dependence, deterministic or probabilistic, allowing us to predict Y in Y given X. And the dependence is known only for samples taken from a training set. And the training set is a set of pairs, X's with labels, with responses. X1, Y1, X2, Y2, and so on. And supervised learning problem is to restore or approximate the dependence. That is, find a decision function. It called also a model, F. And this is, F is a function, is a mapping from X to Y. Which given X predicts Y. So it is important that it is necessary to predict Y not only for samples in the training set, but for new samples, of course. And a lot of examples of such problems exist. And now, what is X like? X. Each X should be represented or coded somehow. And the most usual way is the following. X is represented as a vector of D features. X1, X2, X3, and so on, XD. And each feature can be nominal or categorical. And nominal features can divided into ordered features, unordered features, and numerical features. Numerical features are real features or discrete features. There are other type of features, but we will consider only nominal and numerical features. Sometimes X is difficult. It is difficult to represent X as a feature vector of fixed length. For example, when X is a time series. A time series is a vector of unlimited length. For example, time series can be signal, voice, music, and so on. These are examples of time series. We have an unlimited series of numbers corresponding to the signal. Yeah, what we have in the first moment of time, next time, and so on. Text, also it is difficult to code without loss of information. It is difficult to code without loss of information by a vector of fixed length. Text can be considered as a time series because the text is a series of those, for example. Another example, tree or any graph and so on. And what about y? Y can be nominal. In this case, we have a classification problem. And then we have classification problem. Y can be considered as a label of a class. For example, we have the problem of recognition of images. We have a data set with cats and dogs. We have two classes. And y can be 0, then the image is the image of a cat, and 1, then this is a dog. So we have two labels, zeros and ones, which correspond to cats and dogs, respectively. And y can be numerical. In this case, the problem is called regression problem. Sometimes y can be time series. In this case, the problem is called time series forecasting problem, and so on. Maybe you have questions? No question. Okay. And features of samples usually are written into a table as follows. They have this table. This is an X matrix. Each row corresponds to the sample in the training set. And each column corresponds to a feature. For example, the first feature is this one. The second feature of the first object of the first sample is this one, and so on. And this is the last feature of the first object. And the column, J column, for example, is the column consisting of features of each object. And also we have y's here. This column is y column, and it consists of labels for each sample in the data set. Is it clear? Okay. There is a lot of machine learning methods, and in our course we'll consider 4 of them: linear square methods, logistic regression, k-nearest neighborhoods, and neural networks. But there are other methods, for example, linear and quadratic discriminant analysis, naive Bayesian classifiers, support vector machines, decision trees, ensembles of decision trees, including boosting and bagging, for example, random forests, gradient boosting trees, and so on. And we will use Python. And the necessary libraries are NumPy, SciPy, Matplotlib, Pandas, scikit-learn, and Seaborn. NumPy is a Python library which implements vectors, matrices, and linear algebra algorithms. SciPy implements a lot of scientific computing algorithms, and scientific computing methods, Matplotlib, scientific graphics, Pandas implements the data structures for data frames and serials. Scikit-learn is a core machine learning library which contains machine learning methods. And also we'll use a Seaborn library for data visualizing. If
really kept the ruse up as long as I could, but I was outed by a friend of mine.
Sorry, is this the question? Any question?
No, sir. Sorry, there was just something playing in the background.
Okay. You have to install all these libraries. If you are familiar with Python, you can only install all these libraries separately: NumPy, SciPy, Matplotlib, Pandas, Scikit-learn, and Seaborn. But if you are not familiar with Python, the simple way is install Anaconda package. This is the most popular Python data science platform. Use this link, please. Okay. Anaconda individual edition. I suppose, I guess, I guess we must press download. Okay, Anaconda. Choose your platform. The most popular, I guess, Windows 44-bit graphic installer for 157 megabytes. So download it and install the package as like any package which can be downloaded from internet. Okay, questions here? So, and this package contains all necessary libraries, so you can install it, and that's all. Now I'll run the so-called Jupyter notebook. First of all, okay. First of all, I share you the full screen. Full screen, okay, full screen. Okay. And now okay, I run the Anaconda. This icon, Anaconda Navigator. This requires somewhat time. Okay. Loading applications. So on. I guess, okay, and we don't show again. Remind me later. Update application, remind. Sorry. One moment. Strange. Okay. No. Okay, and this is Anaconda Navigator, and we will use Jupyter Notebook. Jupyter Notebook. So we can launch the Jupyter Notebook. We are recording the video, so you can play it after our lecture. Okay, and this is all documents and folders on my disk. So I can choose any folder or I can create new folder. Yeah. Where? Yes, I have created new folder. Sorry, new folder. Okay, here you are, untitled folder. So I can remove the folder, delete, and this is empty folder, and I can create new notebook, Python free notebook. I press create notebook, and this is a notebook. The title is here, my first Jupyter notebook. Okay, Jupyter notebook. Jupyter notebook. And we have here the cells. For example, this cell. Here you can insert any code in Python. It is rather easy to program in Python. For example, 1 plus 3. Press enter. Press enter. When I press the enter, I'll get a new line. And if I want to run the cell, I have to press Shift Enter or Control Enter or Alt Enter. I have pressed Shift Enter, and this cell was performed, and 5 is the answer, is the output. Yeah, we can use any code in Python. For example, I don't know. Let's program how to print, for example, the table with the squares. First of all, we have to program a cycle. For cycle is like this, for j in range 10. Colon, print j, and let's write. Let's run this cell. Shift Enter. Okay, and I have the list of all integers from 0 to 9. Range 10 means that we have range 1j will be assigned to any value from 0 to this 1 minus 1. Yeah, So from 0 to 9. If I want to, for example, print all squares, say j star 2. This means j to the power 2. Yeah, this one. I have 0, 0 squared, 0, 1, 1 squared is 1, 2, 2 squared is 4, 3, 9, and so on. Or for example, j to the power 3. Okay. Or 2 to the power j. And so on. And so on. If you want, I don't know, 10 to the power j. Yeah. Here you are. Okay. And Python doesn't use some keywords as begin end or parentheses to label the beginning and the ending of the loop. Yeah. Python uses indentations. For example, if I want insert here some other code, for example, print j, print, I don't know, print hello world. Hello world. Okay. Sorry. Hello world. For each j in the range from 0 to 9, we get hello world. Yeah. Because we have the same indentation here and here. This means that all these print commands will be in the loop, in the body of the loop. Yeah, this is clear. And if I use the code like this one, the body of the loop consists of only this print command. Okay, and I will get hello world here after the loop, only one. This is only one example of simple Python code, and I think the Python is a very, very simple, and you can use it without studying it. Okay. Maybe any question? No question. All is clear, isn't it?
Sir, can you repeat it again?
Sorry.
Can you repeat it again? The G part, the first one.
What is the code in Python? And did you understand what is for cycle? Yeah, for cycle
Yes.
For cycle is like in C. Yeah, for cycle.
Mm-hmm.
And but in C, you have to use for something like the analog of this code will be j is equal to 0, j is less than 10, yeah, j plus plus.
Yes.
Then we have to print parentheses, yeah, and these parentheses means the body of the cycle. And here you have to print command. I forgot I forgot how to print in C something printf, yeah, printf or something in C++. As that boom boom out, yeah. something like this one, yeah?
Yes.
And don't forget to use semicolon. And here in Python, we needn't to use parentheses like this one, or begin end words and so on. We will use the indentations. So in this case, we have indentations. So the body of this cycle consists of only one command, one operator print. Okay, it's clear.
Yeah, I got it now. Yes. Thank you, sir.
Okay. And one moment. These are so-called the code cells, the code. But Jupyter Notebook allows us to construct so-called text or markdown cells, markdown. Okay. Markdown. And what is markdown? It allows to use comments. For example, any text here. For example, the title or the caption, the title. The title. And then in this PhD thesis, we will consider blah 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 blah, and so on. This is not the code. This is a text in Markdown notation, and it allows a lot of formatting commands. For example, you can insert lists. For example, first element, second element, unnumbered lists, yeah, and so on. Or if you want numbered lists, or one, some things, some text two, and other text, and so on, free, and so on. Interesting. Okay, here you are. And you can use also LaTeX notation in dollar signs. For example, x 1 2 is the fraction minus b plus minus a square root b squared minus 4ac divided by 2a. Okay, and you get this beautiful formula. All you know what is formula, what formula is, which formula is, yeah? Okay, so you can use this Jupyter notebook not only for coding, but also for reporting your for writing your reports about your coursework, about your homework, on the homework, and so on and so on and so forth. Okay. Okay. Let's go forward. Any question here? No question. And let's return to the presentation, to the slides. This is Anaconda notebook, and this Anaconda Anaconda distribution package, Anaconda package with Jupyter notebook, and you can enjoy all these possibilities online using Google Colab, Colab Research Google.com. Let's go. Okay. So this is almost the same as in Jupyter notebook, but it's not. It's nicer, and it works without installation because it works on the Google hardware. Okay. Let's create. Let's create new notebook. Создать блокнот means create a notebook, yeah, in Russian, but it depends on your language. Okay. And you get this notebook, and here you can do all that things. For example, 2 + 3, or say A is equal to 2 + 3. Sorry. B is equal 2 times A. Then print A and B. Print, of course. And so on. And so on. And also you can use here the text cells. Добавить текстовую ячейку means add a text cell. Yeah, add a text cell. And it is easy to add text here. Don't know. The text here. Blah blah blah. Let's consider a problem concerning something. And this is a WYSIWYG system, so you have here the text and here the results. Yeah. So it's almost the same, but it is running on the hardware or on the Google hardware, yeah, without installing on your computer. For example, it is useful to when you train deep neural networks for deep learning and so on and so forth. Okay, is clear? Other resource is Kaggle. Kaggle is a machine learning and data science community. let's check out the Kaggle.com, and you can see here competitions, interesting data sets, examples of notebooks, Jupyter notebooks, communities, courses, and so on. There is a lot of interesting courses for beginners in Python, Introduction to Machine Learning, Intermediate Machine Learning, Data Visualization, Pandas, and so on and so forth. Introduction to Deep Learning, Computer Vision, and you can check out this course. It consists of lessons, Hello Python, functions and getting help, booleans and conditionals, lists, and so on. First of all, Kaggle is known as a platform for competition. So for competitions, for example, there is a lot of competition here. Some of them provide huge prize, and some of they only knowledge, only knowledge.